Good night, guys.
Good night. Hi, Dave.
Hi.
For our topics today, we will discuss about thermodynamics. We will explain about spontaneity of reaction. So, there are a few parts that I want to give with you. The first part is wait, the definition of spontaneity and the definition of thermodynamics. The other part is characteristic and how to predict a reaction spontaneity. Wait So Ezarin, I want you to cover characteristic and how to predict a reaction spontaneity.
And what about me? What part should I present?
Wait. For you, Dev, I want you to cover about the definition of thermodynamics and also definition of spontaneity of reaction.
Alright.
Wait. What my part? I'm forget about that. Sorry.
You will present about characteristic and how to predict a reaction spontaneity. The
Okay.
first thing, characteristic. Wait, my part, I will cover half of explanation from David, which is definition of spontaneity of reaction, and I will cover the example. Yep.
Okay.
Okay. So start for me. I will explain about characteristic for spontaneous reaction. A spontaneous reaction is a reaction that occurs in a given set of conditions without intervention. Spontaneous reaction are accompanied by an increase in overall entropy or disorder. If the Gibbs free energy is negative, then the reaction is spontaneous. If it is positive, then it is non-spontaneous. What second? Okay. Next, I will talk about how do you predict a reaction spontaneity. For a spontaneous reaction, the sign of delta G is always negative. So, for a spontaneous reaction, you are looking for a free energy of less than zero. If you end up with a free energy of more than zero, then you have a non-spontaneous reaction. That's all for me. So next, Dave, for your part, please.
Okay. Thank you, Eza. Now I'm going to explain about the definition of thermodynamic. So basically, thermodynamic is a science of the relationship between four, which are heat, work, temperature, and energy. In broad terms, thermodynamic deals with the transfer of energy from one place to another and one form to another. The key concept is that heat is form of energy corresponding to a definite amount of mechanical work. Next, the process of a spontaneous process which occur without any external input to the system. A more technical definition is the time evolution of a system in which it releases free energy and it moves to a lower, more thermodynamically stable energy state, close to thermodynamic equilibrium. The sign convention for free energy change follow the general convention for thermodynamic measurements, in which a release of free energy from the system corresponding to a negative change in the free energy of the system and a positive change in the free energy of the surrounding. Therefore, depending on the nature of the process, the free energy is determined differently. For example, the Gibbs free energy change is used when considering processes that occur under constant pressure and temperature condition. whereas the Helmholtz free energy change is used when considering processes that occur under constant volume and temperature conditions. The value and even the sign of both free changes can depend upon the temperature and pressure or a volume. That's all from me. Thank you.
The continuous of what David said, it is because spontaneous processes are characterized by a decrease in the system free energy. They do not need to be driven by an outside sources of energy. For cases involving an isolated system where no energy is exchanged with the surrounding, spontaneous processes are characterized by an increase in entropy. A spontaneous reaction is a chemical reaction which is spontaneous process under the condition of interest. For my part, I will cover about a spontaneous process is one that occurs on its own without any energy input from the outside. For example, a ball will roll down an incline, water will flow downhill, ice will melt into water, and radioisotope will decay. Okay, next, the definition of spontaneity is, although spontaneous reactions are often exothermic, this is not criteria for spontaneity. The best indicator of spontaneity in a reaction is the change in entropy, SODS. The second law of thermodynamics states that for a reaction to be spontaneous, there must be an increase in entropy. Entropy is often defined as a measure of the disorder of a system. This is not a very accurate definition. That's all from us. So there are few questions that I want to ask to you. The first question is spontaneity a good thing?
Okay, for question, for the answer, sorry. For the answer is being open to spontaneous events and allowing our mind time to reflect on things rather than rushing from one planned activity to the next can be very beneficial.
Okay. Next question. David, can you give David the question?
Wait. I have the question. Which uh, wait. For David, the question is thermodynamic science of the relationship between
Four elements which are heat, work, temperature, and energy. And I also have question for Fitria, which is, can you give me two examples of free energy based from the presentation?
Wait. The two example is the free energy that I mentioned in presentation are Gibbs free energy and Helmholtz free energy.
Correct.
Alright, that is done. Okay, that's all from us.
Thank you.
Thank you.
Thank you.